Hi, fourth grade. Hello, welcome to lesson 8 of module 6. Today's objective is to use understanding of fraction equivalence to investigate decimal numbers on the place value chart expressed in different units. We're going to jump right in and get started with today's application problem, which is on page 57 in your Learn books. So turn to page 57 now. This is a great word problem. We're going to have an opportunity to use. Cubes and RDW to unpack this problem and solve it. Let's read through it together and then think about how we can solve. Jashawn had 5 $100 bills and 6 $10 bills in his wallet. It's missing an I in the word bills. But that doesn't matter, of course. So let's start by circling numbers. I've got $500 bills. Let's put that all together. 6 $10 bills. Let's put that all together. And in fact, because we know money pretty well and we know hundreds and tens pretty well in our unit form, you can even make a note, $500 bills, that's going to be $500. And 6 $10 bills, that's going to be $60. In his wallet, Alva had 58 $10 bills under her mattress. If you were really feeling confident about your tens facts, you could tell us that that's going to equal 580. 58 $10 bills, 58 times 10 is 580. Or we should be getting to the point where that comes into our heads pretty quickly. James had 556 $1 bills in his piggy bank. I'm going to leave that as 556. We know that $1 bills are worth $1, of course, and 556 of them would be worth $556. They decide to combine their money to buy a computer. Combine gets boxed. Combine tells us they're going to put all their money together. I know right now I'm not even thinking about subtraction. Chances are we're probably going to be adding. You could be multiplying with a word like combine, but it looks like in this problem we're going to be combining 4 different values. Express the total amount of money they have using the following bills: hundreds, tens, and ones. It's not exactly a question, right? Cube says to underline the question, but sometimes it's a statement or command sentence. Express the total amount of money they have. Total amount of money tells me now I'm confident that I'm adding these values together. I need to find the total amount of money. Make sure your paper's looking like mine. And we're going to find it 3 different ways. This is the first application problem I've ever seen that's 2 pages, I think. But we're going to find this total value and express it with hundreds, tens, and ones, with tens and ones, and with just ones. That would be depending on which bills you use. Let's start by adding all our values together. We have 3 friends, right? Jashawn has $500 bills. Or I guess I should say his $500 bills, right? But the value is 500. He also has 6 $10 bills. We know that that value is 60. That gives us 560. Alva has 58 $10 bills. So we can express that as 58 times 10 That's $580. And lastly, we have James. Uh-oh, we've got another J. So we've got Jashawn and James. James is the one with a bunch of singles, right? Yeah, he's got a bunch of $1 bills, 556 of them. So that's 556 times 1. And of course, we know that gives us 556. We need to express the total amount of money that they have. So let's add these three values together. Pause me right now and see if you can add those together on your own, and then come back to see if you got it correct. Okay, start in the ones column, of course. We have 6. 6 plus 0 plus 0. To the tens column, we have 8 plus 6 plus 5. That's 19 tens. Move a 1 to our hundreds column because that's what that 1 represents. And the 9 to our tens place, that's 9 tens. And now we can add the hundreds column. 5, 10, 15, plus 1 is 16 hundreds, which said more correctly is $1,696 is our total. So we're finished. We're done, right? Great. Let's move on. No, wrong. We still have a lot of work to do. We found the total amount, and now we can do what we've been asked to do, which is express this amount using the following bills. Part A, hundreds, tens, and ones. We have $1,696. If we separate this out into unit form, we would have in the thousands place, 1,000. In the hundreds place, 6 hundreds. 9 tens, and 6 ones. But we don't have any $1,000 bills, right? We need to get to $1,000, represent that $1,000 with $100 bills. And in order to do that, we need 10, right? 10 $100 bills, 10 hundreds makes 1,000. So we also need $100 bills for our hundreds place, which is another 6. So we're going to have 16 $100 bills. That will give us $1,600. $1,600. We have 9 in our tens place, so we're going to have 9 tens. And we have a 6. We have a 6 in our ones place, so we're going to have 6 ones. That's your complete answer for part A. 16 hundreds, 9 tens, 6 ones. $1,696. Now, how can we show that same amount in just tens and ones? So now, not only are we going to have our 9 tens in part B and our 6 ones, but we're going to have to, we have 9 tens and 6 ones from our original value, 1,696, but we now need to show 16 hundreds with $10 bills. In order to do that, you won't need 16, you will need 160. A $10 bill is 1/10 of a $100 bill. So you would need 160 tens to represent the same amount, because remember, this is 1600s. 1600s can also be said as 1,600. If I wanted to show that with $10 bills, 16 would not be enough. 16 $10 bills would give me 160. I need 160 $10 bills to get to 1,600. So I add the value that we had from our original amount, and then when we represent 1600s with tens, we have 160 tens plus 9 tens. That's 169 tens, 6 ones. That's our answer for part B. Part C is the easiest part, I think. We want to represent our amount, which is $1,696, with just $1 bills. Well, that's easy. You need 1,696 ones, because you're just representing 1,696 times 1. And that's it for our application problem for lesson 8. Okay, let's take a look at the problem set on page 59 in your Blue Learn books. Again, we want to focus on representing fractions using decimal numbers and on the place value charts, and we want to be able to do it with different units. Okay, number 1 starts us off, and this is similar to what you're going to see on your exit ticket today, especially when we get down to the place value charts. So please make sure you're paying attention. 25 hundredths is how we say this fraction for number 1A, 25 hundredths. How many tenths is that? I'm sorry, 250 hundredths. How many tenths is that? 250 hundredths is equivalent to 25 tenths. 250 hundredths and 25 tenths are equivalent fractions. They're the same, 250 hundredths and 25 tenths. If we are talking about tenths, we can separate 25 tenths out into wholes and tenths using a number bond. For every 10 in our numerator, we have 1 whole, right? Since our denominator is 10, we have 2 10s in our numerator, so that's 2 wholes, and then we have 5 tenths left over. So we have 2 ones and 5 tenths. 2 and 5 tenths. That's how you would show it as a decimal. And if you were writing it as a fraction, it would look like 2 and 5 tenths. Okay, so far so good. Now let's show it with our area model. Each area model is worth 1, right? You could show it with a bracket and a 1. Each area model is 1 whole. We have 2 wholes, 2 ones. Let's show that by shading 2 whole area models with diagonal lines, nice and neat. Shade in the whole thing. Make sure that anybody who looks can see that you have shaded in 10 tenths of each of these holes. There's 2, 1, 2. Now we need to shade 5 tenths in our last area model. Very carefully count and make sure to shade exactly 5 tenths. 2 and 5 tenths. Okay, it's represented in the area model. Remember that the original fraction we were giving is 250 hundredths. Each of these area models represents 10 tenths, but also 100 hundredths. right? It's not separated into hundredths with rows. It's only separated into tenths and columns, but still you have 100 hundredths, 200 hundredths, 50 hundredths. Or you could say 10 tenths, 10 tenths, 5 tenths. Or you could say 1 whole, 5 tenths. Or you could say 1 whole, 1 half. All different ways to communicate the same information, the same value. Okay, explain how you determined your answer to part A. That's kind of what I just said, right? The easiest way to do it without writing complete sentences, you could write a paragraph of sentences here, but you can also show it with some number sentences, which I think makes more sense for math. So we can say kind of what I was just saying, 250 hundredths we know is equal to 25 tenths. And you could show that by dividing each of these values by 10, right? Divided by 10, divided by 10. 25 tenths, as we separated out in our number bond, that's what I would show here next, can be separated into 2 and 5 tenths. If you can draw me that information with numbers, then I'll know that you understand that concept. So when it says explain how you determined your answer, show me your thinking with a math sentence. Number 2, draw place value discs to represent the following decompositions. We want to separate ones into tenths, 2 ones into tenths. Remember, 1 1 is 10 tenths. 1 whole is 10 tenths. So 2 wholes is 20 tenths. So the way we would solve this, if you remember the way we were decomposing whole numbers very early in the school year, in your place value chart, it's the same. We're going to take 2 ones and we're going to decompose them into tenths. Remember, when we move in this direction in our place value chart, we are decomposing each whole into 10 tenths. So there's 1 whole as 10 tenths, 1, 2, 3, 4, 5, and here's a second whole, 1, 2, 3, 4, 5, as 10 tenths. 2 ones decomposed into 10 tenths. Let's do it again for this second part. 2 tenths decomposed into hundredths. Start with your 2 tenths, and just like we did here, decompose them 1 place value to your right to the smaller place value, 10 times smaller, and mark out 10, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 tenth becomes 10 hundredths. 1 tenth becomes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 hundredths. 1 1 and 3 tenths are 1 becomes 10 tenths. For this next problem, Mr. Hansen started to decompose the tenths, but then I stopped and realized that you actually don't need to do that because they're asking you to put everything into tenths. So we don't need to compose the tenths they give us into hundredths. We just need to take the 3 tenths we were given and add the 10 tenths that come from our 1 whole, so that becomes 13 tenths. I thought they were asking for hundredths. That's what they're doing here. So let's see what happens here. We have 2 tenths and 3 hundredths. So each of these tenths becomes 10 hundredths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5, 6, 7, 8, 9, 10. 10, 20, 1, 2, 3. 23 hundredths. Make sure your paper looks like mine, except don't copy my mistake. Okay, let's take a look at page 60. These are similar to what you're going to see on your exit ticket, so it's important that you understand how to do this. We have to decompose these numbers that are given to us in decimal form into tenths and hundredths. So watch me carefully. I'm going to show you a trick, right? We know that 1 whole equals 10 tenths. We can tell that every time we look at an area model. There's 10 tenths in one hole. If one hole equals 10 tenths, then 1 and 7 tenths, that's one hole again, and 7 tenths of a hole. So it's just 10 plus 7. It's 17 tenths. And you can see the trick I'm going to show you is that you can actually just move your decimal point one place to the right when you are trying to convert a whole number into tenths. And you can move it, I'll show you 2 places of the right to convert a whole number into hundredths. So following that pattern, 10 and 7 tenths is 107 tenths. 2 is 20 tenths, right? If 1 is 10 tenths, 2 has to be 20 tenths. 2.9 tenths is 29 tenths. And 20.9 tenths is 200. I'm sorry, 2.9 is 29 tenths, and 20.9 is 209 tenths. Just by moving your decimal one place to the right, you can find the same value written as tenths instead of as a whole number. And you can do the same thing with hundredths, right? 1 we know equals 100 hundredths. So to show that, we're going to take 1. Remember, one whole, you don't always see it, but there's always a decimal point right there. We're going to take that decimal point in one whole, and we're going to move it 2 places to the right. And if there's not a 0 there in between your 2 points, you can put 1 there. And that tells us that one whole is equivalent to 100 hundredths. You can use the same trick, 1.7. Remember, 1.7 is the same as 1.70. Move your point 2 spaces to the right, and 1.7 becomes 170 hundredths. Ten and 7 tenths becomes 1,070 hundredths, because again, 10.7, 1, 2 places to the right, 1,070. If 1 equals 100 hundredths, then 2 equals 200 hundredths. 2.9 equals 290 hundredths. And 20.9 equals 2,090 hundredths. Please make sure your paper looks like mine. And at the bottom, we're completing this chart, and we just have 4 different ways that we can show the same value. 2.1, 2 1/10, written 2 different ways in tenths and 2 different ways in hundredths. So doing the same thing with 4.2, that's 4 2/10, written in unit form as 42 tenths, or in fraction form as 42 over 10. And it would be 420 hundredths, or 420 over 100. I would like for you to try to complete these 3 by yourselves now. Be sure to complete them, because I'd like to see your answers and discuss them when we meet to go over this work in our small groups. So take your time, finish those 3, and based on the work we just did now, you should be able to complete your exit ticket and submit it by the end of the day. Thanks for paying attention. Have a great night. See you tomorrow.